Hello. In the last lecture, we have discussed about the DDA algorithm. Now we are proceeding towards the Bressenham line drawing algorithm. So first of all, we have to discuss about the problem which we have occurred or faced in the DDA algorithm. So you can able to see the number of pixels which we are plotting here. These are the line segment which has to be drawn through the DDA line algorithm. But while we are using the DDA line algorithm, which pixel has to be turned on, which has to be decided in the through the algorithm. So you can able to see here while we are plotting the or turning on the pixels through the DDA algorithm, we can face the staircase problem in this. So the curves and other shapes which we would like to implement here, it is not possible through this. So in this, if we want to switch on the pixel, which pixel should be switch on? You can able to see here the question mark represents whether we have to switch on the pixel where it is 3,3 or 3,2. So it will be the confusion in this, that the nearest pixel, which one will be the corrected or the approximate nearest pixel through which the line can be formed in a correct way. So in this simply, if we are going to plot, so we are having the two options, that is 3,2 or 3,3. Which pixel should be turned on to form a correct line which we would like to implement through our problem situation. So here we can able to identify this which is the correct pixel. So to resolve these issues, the next algorithm which has been proposed, it is a Bressenham line algorithm. Bressenham line algorithm only uses the integer calculation and it is very efficiently used for the incremental method. It produces the mathematically correct results using the simple calculation, as well as it is accurate and efficient. That's why the Bressenham line algorithm is more appropriate for calculating the coordinates of a line segment. In the Bressenham line algorithm, we are going through with the algorithm with the slope less than 1. There is a algorithm for the slope greater than 1, but we are first of all we are going through with the slope less than 1. So in the first step, we have to just consider the two input of the line segment, that is the starting and the ending point of the line segment. In the second step, we have to just plot the initial point of the line segment, that means x0 and y0. Now we have to calculate the constants, that is the dx and dy, and twice of dy and twice of dy minus of dx. So with the help of the dx and dy, we can further calculate all those values. So it is not compulsory to calculate here only. Okay, and first of all, for the calculation or for finding out the first value where we have to plot the pixel, so we have to calculate the decision parameter. So decision parameter can be calculated with the help of an equation, that is p0 equals to 2y minus of p0 equals to 2 del y minus of del x. Through this, we are going to find out the first decision parameter from where the line has to be started. In the fourth step, we have to first find out, that is k equals to 0, and perform the following test, whether the decision parameter is less than 0 or greater than 0. If it is less than 0, then that means we have to increase the x-axis value, as well as we have to make the y value as a constant. And again, we have to calculate the decision parameter with the help of a next equation. You can able to see here, we can able to identify, this is the equation, pk plus 1 equals to p of k plus 2 del y. So 2 del y is initially asked to calculate earlier in the step third, so we can directly put the values here. Otherwise, the next point can be calculated if the decision parameter is greater than 0 with the help of the point, that is xk plus 1 and yk plus 1. And then we have to again calculate the decision parameter pk plus 1 equals to pk plus 2 del y minus of 2 del x. This is the complete algorithm, and until and unless we have to repeat these steps until we cannot get the endpoints of the line segments. So Bressenham line algorithm, we can go through with the step-by-step procedure. That means we have to store the two endpoints of the line segment, and again we have to plot that particular points, and then we have to calculate the values. So here we can consider a example, that is endpoints of the line segment is given to us 30, 20 and 40, 28. So first of all, we have to calculate the slope of the line segment. Slope of the line segment can be calculated with the help of y2 minus of y1 divided by x2 minus of x1. So through this example we can able to calculate 28 minus of 20 divided by 40 minus of 30, that is 8 by 10. So we already got the slope of this line segment is 0.8, that means it is less than 1. So we are going to follow the Pressnahme-Line algorithm for the slope less than 1. Now the value of dy equals to 8 and del x equals to 10. So first of all we have to calculate the decision parameter before proceeding further. So first decision parameter can be calculated with the help of equation twice of del x minus of twice of del y minus of del x. So here we are just putting the value 2 into 8 minus of 10, that is 16 minus of 10. So we will get the value P0 equals to 6. Now the constants of 2 del y and 2 del y minus of del x are here, can be calculated. Twice of del y, that means 2 into 8 equals to 16, and twice of del y minus twice of del x, that is 2 into 8 minus 2 into 10, that is 16 minus of 20. We will get the value, that is minus 4. So we got the value. So after this we can calculate each and every value with the help of the parameters. Okay. So this is the table which we are going to get it. That is, first the k is 0, the decision parameter is 6, and next value is 31 and 21. After this we are going to calculate the decision parameter. The next value is 32, 22, and so on. We are going to proceed till we cannot get the last endpoint or the endpoint of the line segment, that is 40, 28. Till this coordinates we have to calculate, and again and again we have to calculate the decision parameter as per the values have been calculated. So these are the calculations. So we have calculated one by one. So p k plus 1 we have calculated, that is p k plus 2 del y minus of twice of del x. That means if we are going to calculate 6 plus 16 minus of 20, that is 2. This represent it is greater than 0. So that means we are going to follow the decision parameter is greater than 0. So we have to follow the case second. So in this way we are going to calculate all the values. Thank you.